Hello. I'm going to review the solving right triangles. I know we did this prior till the break, but I want to hit it again because it is on the final exam. I want to make sure we're okay on that. You will need a calculator. If you do not have one of these calculators, you can use a calculator on Desmos. I'll post a link in the description so you guys all know where to find that. But I'll be using this calculator. It's the one I'm most familiar with. Desmos also has this. Any calculus, sine, cosine, tangent, inverse, cosine, sine, and tangent will also work. Okay, key fact here is SOHCAHTOA. It's all up here. We went over that. I'm not going to waste your time there. As well as Pythagorean theorem and 180 degrees in a triangle. Okay, so we are going to solve a triangle. Now, solving a triangle means we need all the angles, all the sides. Okay, we went over this earlier, but we're going to re-go over it. So we're going to go ahead and take and solve for whatever we can. Well, first of all, let's solve for angle B. All right, angle B. All right. We know that A is 28, that is 90, so this has to be 180 degrees minus 90 degrees minus 28 degrees, which is 62 degrees. Okay, so we know this is 62. And it's exactly 62. It's not a rounded answer. We actually found that number. That's important. A lot of times, you're going to get rounded answers. Well, we don't want to use rounded answers. We want to use answers that are not rounded, okay? So if at all possible, we want to use the numbers that were given. But again, if you can't, then we'll have to do it another way. Okay, so now you have to decide if you're going to solve for A or B. So let's solve for A. So in SOHCAHTOA fashion, we have opposite of 28. Now you could use 62, but we have opposite and hypotenuse. That's going to be sine. So we're going to have sine of 28 is equal to opposite over hypotenuse, which is A over 14.8. Now again, you will need a calculator for this because you're going to have to type in sine. Make sure that calculator is in degrees. Go ahead and do that and solve this. Pause the video. Okay, welcome back. If you solve correctly, you're going to end up with approximately 6.9. And again, they don't give us units, so 6.9 is fine. So now we're going to go ahead and find B. Find B. And when you find B again, you can use the 62, use the 28. I'm going to go ahead and use the 28. So we have adjacent over hypotenuse, which is cosine. So we're going to have cosine, okay, 28 equals adjacent over hypotenuse, okay? And again, you go ahead and solve that. Pause the video. All right, you should get approximately here 13.1. 13.1. Now let's check. We have angle A, angle B, angle C, side A, side B, side C. We have solved this triangle. All right, go ahead and see if you can solve this triangle on your own. Pause the video. Do so at this time. Welcome back. Okay, so first thing you're going to notice, we could easily solve for B without trig. We're going to use the Pythagorean theorem. So we're going to do A squared plus B squared equals C squared. And they have it nicely set up so A, B, and C are in the right spots. So we're going to go ahead and take 9 squared plus B squared equals 20 squared. Solve for B, and you're going to get B is equal to square root of 319, which is approximately 17.9. Now again, I will not be using B in any of these calculations due to the fact that we did round that. All right, so now we want to find angle B. So angle B, I'll do that in this blue marker, okay? So we're going to want to use angle B. I don't want to use side B, so I'm going to use A and C. So we have adjacent hypotenuse, that's going to be cosine. So we're going to go cosine B equals adjacent 9 over hypotenuse. Now again, how do you solve this? Use inverse cosine. So we're going to take inverse cosine of 9 over 20, and that's equal to B. Type that in a calculator, and you should get approximately 63.3 degrees. Then we're going to now try to find angle A. Now, angle A, again, is just 180 minus 63.3, okay, minus 90. So that's going to give us 26.7 degrees. So now we know A, B, C, A, B, and C, so we've solved this triangle. All right, very good. Now we're going to get into some word problems. And again, drawing the picture helps. Sometimes I will, sometimes I won't. All right, surveyor stands on level ground 100 feet from the base of the lighthouse. He measures the angle from the ground to the top of the lighthouse to be 18, round to the nearest foot. What is the height of the lighthouse? So again, I'm going to go ahead and draw, put my known information there, and we know this is 100, okay? So again, we want to find the height. We'll call that x. So we have opposite and adjacent, that's tangent. So we're going to get tangent 18 degrees equals opposite over adjacent. Go ahead and see if you can solve that. Take your time, pause the video. Okay, welcome back. All right, so you should have gotten h is approximately 32 feet. 32 feet. Okay, 32 feet. All right, so now we have a similar problem, except this time, remember we did one like this. You have this little guy here who's 5 feet tall, so you're going to want to keep that in consideration when calculating the height. So why don't you check and see if you can do this on your own. Pause the video and try. Sure, come up. All right, welcome back. All right, my daughter's going to read that. Read this one right here. Louder. Surveyor.
Surveyor stands on level ground 90 feet from the base of a lighthouse. He measures the angle from eye level to the top of the lighthouse to be 28 degrees. If the surveyor eyes is 5 feet above the ground, what is the height of the lighthouse? Round to the nearest foot.
All right, thank you, Ava. Okay, so now we have to understand this is 5. We're going to call that x, and we get this triangle. It tells me we're 90 feet, so this is 90. So whatever we get for x, we're going to have to add what? 5 to that. Don't forget that, because I guarantee if it's multiple choice, one of the answers is going to be the one without 5. All right, so what we got here is, again, we know this is 28 degrees. So we know we have opposite adjacent, your friend tangent. So we're going to get tangent 28 degrees is equal to, and again, we're going to take x over 90. So go ahead and solve that, and then you should have got that x is approximately 48, but you have to add the 5. So the height is approximately 53 feet. All right, hopefully you got that. All right, moving on to the next problem, okay? So on this problem, it's like the clock tower again. We did this one as well, okay? We did this one as well. All right, so we want to make sure we determine the height here all the way up to the top, and then the height to the here and subtract the two. All right, so my daughter's going to go ahead and read this one, and we'll get started on it.
To determine the height of a window in the top of a lighthouse, two measurements are taken from to the ground 90 feet from the base of a lighthouse. The angle of elevation from the ground to the bottom of the windows is 36 degrees, and the angle of elevation from the ground to the top of the window is 42 degrees. Find the height of the window to the nearest foot.
Alrighty, people. So what we want this purple height. But in order to get it, we're going to have to find this green height, and we're going to have to find this blue height and subtract the two. So we're going to call the smaller height x. We're going to call the longer height y. All right, so you can call them any letters you want, but that's what I'm going to do. So we're going to start with the smaller, and again, the angle is from the top to the bottom of the window is 36. So we're going to have 36 to the bottom of the window in here. Okay, whoops, that's supposed to be blue. Let's change that.
Blue's over there, Daddy.
Thank you. So we have 36, okay, degrees. And then in the bigger triangle, we'll get to that in a second. So we have we have a known value of 90 again, so we're going to have opposite and adjacent. You're a friend of mine, tangent. So we're going to get tangent 36 equals opposite over adjacent. And then when we do the green, we're going to get tangent 42 equals opposite y over adjacent 90. Go ahead and solve for x and y. Pause the video now. All right, should have got x is approximately 65 feet, okay? And you should have got y is approximately 81 feet, okay? So we have to subtract 81 minus 65, okay, which is 16 feet. Now, this question says, from the given information, can we determine the height of the lighthouse all the way to the top? And the answer is no, because we don't have that angle. We'd have to take a guess. So the answer is no for that. All right, moving right along here. Moving right along. Now we have an observer in a helicopter hovering 200 feet above the sea, makes measurements to two buoys, points A and B below. She finds the angles of depression. Again, that's down. You got to watch. This is the be careful on. We'll get to that in the picture in a second. Assuming the observer is in the same vertical plane, what is the distance between the buoys? So you got to be careful. So it doesn't matter exactly which way you do this, but you want to make sure you put them in the correct spot. So we know she finds the angle of depression to be 44 respectively. So A's angle of depression is 44. That's going to go right there. And B's is 35. But notice, those values are not in the triangle. So one thing you have to understand is you have alternate interior angles. See that horizon line and that are parallel? So 44 can shoot right there, and 35 can go right there. So very important to know that. It's a trick here. We know we're 200 feet, 200 right here. So now we need to find the distance between A and B. You can't find that all by itself. You're going to have to find this distance. We'll call this point J, okay? So A to J and J to B, we'll have to find those two spots. So in order to do that, let's call this side X, and this side we'll call Y. No, we'll call it Y, okay? So we're going to go ahead and solve for X. We have opposite and adjacent. Seems like tangent will not leave us. So we got the tangent of 44 equals 200 over X. Now be careful when solving this. You're going to have to multiply both sides by X, then divide by tangent 44. And then for the other triangle, you're going to get tangent 35 equals 200 over X, or over Y, excuse me. All right. So we're going to be over Y. Go ahead and solve both of those and see what you get. Pause the video. Okay, so welcome back. We have X is approximately 207. Y is approximately 286. So the distance is X plus Y. So you have to take 207 plus 286. So a total of 493 feet. Okay? All right, so that ends those examples. Now we're going to head down to bearing. Bearing. Now remember, bearing has three things. It has up and a down, a north and a south, an angle measurement, and then an east or a west. Okay, so an east or a west. So this particular angle right here would be south 40 degrees west. And you have to watch. Remember, some of these got tricky. You had to draw the extra pictures and all that. So, all right, so here's some basic problems. Find the bearing from A to B. Now be careful, B to A would be different. You got to be real careful there. All right, so we practice in class, so go ahead and figure out numbers 7 and 8 on your own. All right, so welcome back. We have north 50 degrees east, and we have north 34 degrees west. Okay? Now, how did I get 34? It says 124. Hopefully you guys realize that a straight angle is 180, okay, 180. So we can figure this out, okay, by taking 124 minus 90. and that will give you 34, okay? And again, how do we know that? This is 90, okay? This picture, this is 90. So to get the missing piece, just take 124 minus the 90, gives me what's left over. All right. All right, try 9 and 10, 9 and 10. All right, welcome back. All right, so 9 and 10, here's what we got. What is the bearing did you get? Okay, so for 9, got to be careful. There are multiple ways to do this problem, multiple ways. You can go 180 to there, and then you can figure out this angle, but you need to know this distance to there is 270 degrees. We did that before in this class, as a matter of fact. So if that's 270, what's left over? Subtract the 220, and you'll get an angle of 50 degrees. So that's going to be south 50 degrees west, okay? Over here, this says 19, so you would think it's 19. It is not. Remember, bearing is from the north-south line. We need that blue angle. So to do that, you're going to take 90 minus the 19, so you're going to get the following. South 71 degrees east, okay? South 71 degrees east. All right, now, here's that A to B. It's going this way. You would think it's 30 or 90 minus 30, but you got to be careful when doing that, okay? You have to be real careful when doing that. So, the key here is to draw in this extra line, okay? And from that, you want to find this, okay? So now you have a 30, 90, so that must be 60, okay? 60. So that's going to be 60. So that tells me now that A to B, here's my new north-south line. I just transitioned it over to there is 60. So we're going to have south 60 west. Okay, south 60 west. All right, number 12. Ava's going to read that. Go ahead.
A boat leaves a marina and sails north for 30 minutes. Then west for 2 hours. If the boat's average speed is 12 miles per hour, find the bearing for the return trip round to the nearest degree.
All righty. So, no picture, our enemy. So we want to draw our picture, okay? So, here's our north-south line. Okay, boat leaves marina and sails north for 30 minutes and then west for 2 hours. So again, your starting point is here. So we're going to go up for 30 minutes and then west for 2 hours. So again, we're going to end up with something that looks like this. Okay? And from that, we're going to get a right triangle, of course. That's how we do these things. So we need to figure out how far you're going. Well, if I went for 30 minutes at 12 miles per hour, okay, that's 0.5 hours times 12, okay? So if you do that, you're going to get 6 miles. And that is the distance here. Then we're going to travel west for 2 hours. So it's going to be 2 hours times 12. It's going to be 12 miles per hour, sorry. And then the hours will cancel and you'll get 24, okay? 24 miles, and that's this west distance. Okay, so then it says, okay, we want to find the bearing for the return trip. So here's where you got to be creative. Draw your new lines in. So we want this angle right here. Okay, we want that angle right there. Okay. Well, can't find that angle. You want to know why? It's not in the triangle. So what we're going to do is we're going to find x. That's 90. We'll take 90 minus x. That'll give me the red angle. So how are we going to find x? Gee, I wish there was a formula or some way. Oh, wait, so could Toa. we have, again, opposite and adjacent, your friend and mine, Mr. Tangent. So we're going to get tangent x equals opposite over adjacent. We're going to solve for x. To do that, you're going to use inverse tangent. So x is inverse tangent, okay, of 6 over 24. You're going to go ahead and type that in the calculator, and you'll get approximately 14 degrees. But that's not my answer. That's this answer. You're going to want to take 90 minus 14 degrees, and that 90 minus 14 degrees will give you the actual answer of 76 degrees. Okay. All right. Ava's going to read this last problem. You're going to do it yourself.
A plane leaves an airport at a bearing of north 38 degrees west and travels at 280 miles per hour for 2 hours. The plane then makes a 90 degrees left turn and travels 500 miles to its destination. Find the bearing required to locate the plane from the airport.
That's right. I think there's a typo. That should say plane, huh? We're not
Yeah. Yeah, so you should put an E over there.
I will. All right, have a seat, bud.
Around to the nearest degree.
Okay, so after that glorious reading of the problem, pause the video, see if you can solve this problem. Okay, welcome back. So, again, I'm going to draw my north-south line. You have to be careful here. The plane leaves the airport at a bearing of north 38 degrees west. Okay, so that is this way. Okay, and this angle is 38. Again, it's from the north-south line. Then it travels 280 miles per hour for 2 hours. We're going to use that in a second. Plane makes a 90-degree left turn. So that's like that. Travels 500 miles to its destination. So wherever that's at, somewhere over here. And then it wants to say, find the bearing required to locate the plane back to the airport. Okay, so there's our right triangle. Okay, so now you're going to want to draw another bearing. Okay, right there. So we need to calculate this angle, but again, probably can't calculate that angle. Okay, probably can't calculate that angle. So we're going to have to calculate this angle. All right. This angle and figure out exactly what it takes here, okay? So, again, we want to find the bearing required to locate, oh wait, we're locating from the airport, I'm sorry, so we don't want any of that.
Yeah,
what we want is, we want to locate the plane here, so we need to find this angle, okay, that angle, okay, so we need that angle. So, we know this is 38, so we need to find this angle. We'll call that angle A for Ava. Okay? So, we're going to call that A. Alright, so we're going to find angle A. So we need to know this side. Well, 280 miles for 2 hours. So you're going to take 280 times 2. Okay, so that's going to be 560. And then they already told me, 560, and they already told me this is 500, okay? So now we have opposite and adjacent again, your friend tangent. So you're going to get tangent A equals 500 over 560. Take the inverse tangent. You should have got A is approximately 42. So that's 42. So we're going to have to find this whole green degree. So we're going to take 42 plus 32.
42.
And that's going to be 70 or 80.
84, I think.
Oh, I'm sorry.
74, I think.
Plus 38. 38. So that's going to be 80 degrees. Sorry.
Yeah, it's 80.
Can't read my own writing sometimes. All right, so that concludes the lesson on right triangle trigonometry.
That is good.